Hi everyone, my name is Praful Kumar. So today we'll be generating a CORDIC algorithm using IP generator from Quartus Prime Lite. So for that you have to go to File, you have to create a new project. Click on New Project Wizard here. You can choose a working directory and you can give project a name. So since I've already created a project, so I'm skipping this step. So let me import my project. Okay, so the next step is you have to search for CORDIC algorithm in the IP catalog. So as you can see here, it's present. So since I have already created it, I'll just show you here. Okay, so you have to set the data input bits. So we are selecting 7 as fraction, so the total is 10 bit, so and we are using one of it as signed. So for output we are using 3 for fraction, the total width is 5, and we are using signed here. So you go into performance and you choose the frequency. Okay, and then you have to choose a frequency. So since our board supports 20 megahertz, so we'll put in 20 here and we'll click on generate HDL. Since I've already generated a HDL for this, I'm skipping this step for now. Okay, so the next step is you have to create a constraint file, synopsis design constraint file. So the way how you do it is you go into file, you click on synopsis design constraint file, and then you click OK, and then you click OK. So as you can see, this is the SDC file I've created. Okay, so now the next step is you have to import the project files. Right click on this, click on add project files, click on this, go here, and you can directly select this. Once you select this, all the related project files will be imported into your project navigator window, as you can see here. So once this is done, you right click on this. I'll make this as top level entity. Okay, now I'll compile. So let me show you the Verilog code here. So this is the sine cos module. So if you can see, we are instantiating the sine CORDIC algorithm here. So basically we are having phase radian input here, that is 10 bits, and here I have modified the code so that the output gets displayed onto the 7 segment display. So I'm using 5 of those display here, and as you can see, this is the logic for switching between cos and sine value when we use the push button. Okay, here if you can see, this is the cos display module in which I have mapped the output to 7 segment display. So this is the debounce circuit. So since it's a push button, so there is a debouncing effect. So to reduce it, I have created a module called debounce, and then I'm using it. So now I have successfully compiled the code. So I'm going to upload it to my FPGA board. So the way how you do it is you click on program device. So once this is done, you right click on this chip, you click on change file, you select the SOF file. I think it's in output files, right here, SOF file. Click on open. Okay, once this is done, so we are programming the board. So tick this option and click on start. Okay, now we have successfully uploaded the code into the board. So I'm gonna show you the output of it now. I'm going to show you the output on the FPGA board. So for the first test case, I have the radian value is 0, so I have all zeros. So as you can see, when this is the case, the sine 0 value is 0. So this is the sine 0 value that is being displayed. So the first 0 is nothing but the sign, the positive or negative. So if it's 1, that means it's a negative value. So let me show you the cos. So this is nothing but the cos 0 value. If you can see, it's showing 1, so cos 0 is 1. So for the next test case, I'm gonna test for pi by 2. So for pi by 2 we have 0 0 1 1. So this is 1 1, and then 0 0, and then 1 0 0 1. So this is pi by 2, phase in radian for pi by 2. So for sine pi by 2, it's 1. So this is cos pi by 2. The one in the output is cos pi by 2. So let me show you for sine pi by 2 now. Let me switch this. So if you can see, sine pi by 2 is 1. So this was the second test case. So I'm going to test for pi also now. So for pi, the phase in radian is 0 1 1 0 0 1 0 0 1 0. So yeah, so this is pi, phase in radian for pi. So for sine pi, it's 0, that is showing here. This is sine pi. So for cos pi, it is minus 1. So this one indicates the negative or positive. If it's 1, it's negative. So it's basically minus 1. So yeah, this proves the working of a CORDIC algorithm.